Good afternoon, everyone. So, in the last class, we have finished section 4.3. So, in today's class, we'll start section 4.4, and this is the last section from this chapter. And after that, we'll start chapter 5. And from chapter 5, we are not going to cover all the sections, we'll just cover only two sections from chapter 5. Okay. So this section is about also continuous distribution. So this is about exponential distribution and gamma distributions. And both of them are continuous distribution. So the exponential distribution has one parameter and the parameter is lambda. So it is the PDF function is fx lambda. X is the random variable and lambda is the parameter, which is equal lambda times e to the power minus lambda x. So sometimes some book also use other PDF function, and which is, but we'll follow this one for this course. So you can also use this PDF function. So if x lambda is equal 1 over lambda e to the power minus x over lambda. But we are not going to use this PDF function for this course. We are going to use the first one. F of x lambda is equal lambda times e to the power minus lambda x. Okay, so the expected value of x or the population mean of x is for exponential distribution. It is expected value of x, which is the population mean, which is equal 1 over lambda. So mu is 1 over lambda. But if you use this PDF function, then the mean is just lambda. But since we are not using this PDF function, we are using the first one, the mean will be 1 over lambda. So you have to be very careful when you are finding the mean from the exponent for the exponential distribution. You have to be careful about the PDF function. Which PDF function you are using in this case is very important. Okay, and the variance is sigma square, the population variance, which is equal 1 over lambda square. So what will be the standard deviation then? Anyone? If the variance is 1 over lambda square, so what is the standard deviation in this case? Yeah, 1 over lambda, because the standard deviation is the square root of variance, right? Thank you. Okay, the CDF function is, we can derive the CDF function from the PDF function. So we know the definition of the CDF function, and which is the CDF f of x is equal probability of x less than equal x, right? So this is the definition of the CDF function. So then it will be negative infinity. Okay, I need to mention one more thing here. The support of x, support means the values of x for which this function is defined. This function is defined when x is not negative. X is either positive or 0. X is greater than equal 0. For the other values of x, this function is 0. So the PDF function will be non-zero only when x is greater than equal 0. So in this case, the definition is negative infinity to x f of x dx. So here the lower limit will be 0 because the function is defined from 0 to infinity. So 0 to x, and the PDF is lambda e to the power minus lambda x dx. Now you need to integrate this function. So this is x. We can take it will be lambda times, if you integrate this one, it will be e to the power negative lambda x divided by negative lambda, and x is from 0 to x. because the lower limit is 0, the upper limit is x. Or you can use actually here different variable, so that you do not get confused with x. You can you can use some other variables. You can use y here for the integration. You can use e to the power minus lambda y dy. Okay, now we can cancel out this one and this one. You need to plug in the value of x. So x is the upper limit is x, so it will be negative e to the power minus lambda x is just x, and minus negative e to the power minus lambda times the value of x is 0. And if you simplify this one, then it will be minus e to the power minus lambda x. This is negative, so it will be plus, and e to the power minus lambda times 0 means e to the power 0, and which is just 1. So you can just write 1 minus, this is equal 1 minus e to the power minus lambda x. So this is the CDF function. And you can see here the CDF is 1 minus e to the power minus lambda x, and x is greater than equal 0. So this is the CDF function for exponential distribution. And you will be using this function to find the probability. So exponential function often used in engineering and science problems for models the distribution of times between occurrence of successive events. If you want to know the distribution of times between occurrences of successive events, this is also kind of waiting time distribution. It is close to Poisson distribution, but the only difference is the Poisson distribution is discrete distribution and the exponential is continuous distribution. But both of them are waiting time distribution. This distribution is closely related to Poisson. We'll go over an example. Let x denote the distance. So till now we know the PDF function and the CDF function of the exponential distribution. The PDF was f of x is equal lambda times e to the power minus lambda x, and CDF is 1 minus e to the power minus lambda x, and where x is greater than equal 0. So here x denote the distance that an animal moves. So x is the random variable. So since this is the distance, so this is continuous random variable, and it is given that x has an exponential distribution with parameter lambda. So we are given the parameter value, which is 0.01386. So this is the parameter value of lambda, and x is exponential distribution with lambda. So what is the probability that the distance is at most 100 meter? So x is the random variable which denotes the distance. Now we have to find the probability where x is at most 100 meter. So x cannot be more than 100 meter. We have to find this probability. So since this is exponential distribution, so we'll use you can use the CDF function. Since this is x less than equal 100, and we know that f of x is probability of x less than equal this number, right? Since we have x less than equal 100, so this is the CDF at x is equal 100, right? So you can directly use the CDF function. But if you use the PDF function, then you have to integrate every time. So for this one, you have to do integration. For this one, you have to do integration. That's why CDF function is very important to find the probability. You can directly find the probability using the CDF function without performing any integration, right? Now you will plug in. So we know that the lambda is 0. Where is the lambda? The lambda is 0.01386. And the CDF function is 1 minus e to the power minus lambda x. So we'll plug in the value of lambda and x here. So minus lambda is 0.01386 times the value of x is 100. So if you simplify this one, you will get the probability is 0.750. So that's mean the probability is 0.75. Okay. The part B is not part B. There are two more parts in part A. So at most 200 meter. So the probability is at most 200 meter. That's mean we have to find the probability where x is less than equal to 0, 0. So this is, you can also CDF function for this one. So that's mean f200. Now plug in this number, minus 0.01386 times 200. If you simplify this one, then it will be 0.937. So this is the probability that the distance is at most 200 meter. The next part is between 100 meter and 200 meter. That's mean we have to find the probability where x is between 100 and 200. From the properties of the CDF function, you know, you have to subtract the smaller value from the bigger one. So that's mean f200 minus f100. And you already know the value for f200, which is 0.937, minus f100 is 0.750. Now you need to simplify this one, then it will be 0.187. So this is the probability that the distance is between 100 and 200. Part B is, what is the probability that distance exceeds the mean distance by more than 2 standard deviations? That means x is greater than 2 standard deviations from the mean. So what does it mean by 2 standard deviations from the mean? If our mean is mu, 1 standard deviation from the mean means mu plus sigma. And 2 standard deviations more from the mean is mu plus 2 times sigma. 3 standard deviations more means, okay, mu plus 3 sigma. If you are said that 1 standard deviation less than the mean, that's mean mu minus sigma. 2 standard deviation less than the mean, mu minus 2 sigma. Similarly, 3 standard deviations less than the mean, that's mean mu minus 3 sigma. So here we have to find the probability where x is 2 standard deviations more from the mean. So that's mean x greater than mu plus 2 sigma. Now the question is, do we know the value of mu and sigma? We do not know the value of mu of sigma yet. We know the value of lambda. Lambda is 0.01386. So this is the value of lambda. How can we calculate the value of mu and sigma? Mu is 1 over lambda. And sigma square is, we know that 1 over lambda square. So sigma is 1 over lambda. Since we know the value of lambda, we can calculate the value of mu and the value of sigma. Now we need to plug in this value here. Then it will be x greater than mu is 1 over lambda. So that's mean 1 over 0.01386 plus 2 standard deviations from the mean. So standard deviation is 1 over lambda. We have to find this probability. If you simplify this one, then it will be x greater than, if you simplify this part, this is 216.45. So how can we calculate this probability? You can use the CDF function. Since this is x greater than, so we have to use the complement. That's mean 1 minus probability of x less than equal to 216.45, right? So we can use the complement because we want to use the CDF function. And CDF function always give you the probability where x is less than some number. If you have x greater than some number, then you have to take the complement if you want to use the CDF function. Then 1 minus this probability is, if you simplify this one, it will be then 0.950. Then it will be 0.050. So this is the probability. Okay, so part C is we have the CDF function. We need to find the median. And the median value means you have to find the value of x for which 50% of the observations are on the left side and 50% of the observations on the right side. So that's mean 50% density will be on the left side and 50% density will be on the right side. So that's mean the probability will be 0.50. So we have to find the median, and at the median the CDF is equal 0.5. At the first quartile, the CDF is 0.25. At the 75th quartile, the probability is 0.75. So you have to find this one. Find the find Q1 and Q3. So this question is also part of your quiz. Okay, and do not share this question with your other friends. Okay. So we have to find the median. F of x is equals to 0.5. Now we have to find the value of x. So we know the CDF function, which is 1 minus e to the power minus lambda x is equal 0.5. So this is 1 minus e to the power. We know the value of lambda, which is 0.01386. X is equal 0.5. Now you need to simplify this one for x, and if you simplify this one for x, then it will be this equal 0.5. Since you have exponential here from Collatz algebra class, we know that if you have exponential and if you want to remove it, then you have to take ln, which is natural logarithm. That's mean the log with base e. Then it will be the power of e, which is 0.01386, is equal ln 0.5. So this is the properties of natural logarithm. So now you can use calculator, and if you simplify this one, then x will be 50.01. So the median value is 50.01. Do you have any question? Okay, so this is the part of your quiz. Find Q1 and Q3. The next one is gamma distribution. So the PDF for gamma distribution, we have two parameters. In exponential distribution, we have one parameter. In gamma distribution, we have two parameters. One is alpha and the other one is beta. So the first one is, this is called alpha, and this is called beta. So we have two parameters here. So the PDF is f of x alpha beta is equal 1 over beta power alpha times gamma alpha. So this notation is called gamma. This notation is called gamma notation. And this is also related to factorial notation, if you know about factorial. So how many of you know this notation, gamma? What is the value of gamma 3? Okay, so I think many of you have not seen this notation yet, right? So this notation is called gamma notation. So how many of you know this notation? 3 factorial. This notation. This is called factorial. So how many of you know factorial notation? Okay, some of you know. Okay, that's good. Yeah, you have seen factorial. So the difference is gamma n is equal n minus 1 factorial. So if you know factorial, then now you will also know gamma. Gamma is n minus 1 factorial. So that's mean gamma 4 is equal 3 factorial. So what is factorial? Factorial means you will start multiplying the numbers from 3 up to 1. So 3 factorial means 3 times 2 times 1. This is 6. Similarly, 4 factorial means 4 times 3 times 2 times 1. So that's been 24. Now the gamma 3 will be then 2 factorial, right? Because gamma n is n minus 1 factorial. So gamma 3 is 2 factorial. So gamma 3 will be then 2 times 1, 2. And gamma 4 will be then 3 factorial. So that's mean 3 times 2 times 1. It will be 6. So for the gamma notation, you will be starting multiplying from the next number, like from the previous number of that number. So gamma 4 means you will start from 3. 3 times 2 times 1. Gamma 3 means you will start from 2. 2 times 1. But for factorial 3 means you will start multiplying from 3 up to 1. And you will start multiplying from, for gamma 4, sorry, factorial 4, you will start from 4. So 4 times 3 times 2 times 1. So this is factorial. Okay. Is it clear? Or do you have any question? So the PDF function is fx alpha beta is equals to 1 over beta power alpha times gamma alpha times x to the power alpha minus 1 e to the power minus x over beta. And here x is also non-negative. So that's mean either 0 or positive. So this is the PDF of the gamma function. So the expected value of the gamma function is the multiplication of the two parameters. That's mean the mean is equal alpha times beta. If you have this type of PDF function, if the gamma function is defined with this PDF, then the expected value of x is the multiplication of the two parameters. That's mean alpha times beta. And here the variance is sigma square, which is alpha times beta square. The variance is alpha times beta square. And the CDF function probability of x less than equal x is denoted by fx alpha beta, and who is also can be written as f x over beta comma alpha. And we use this notation for using the table. You will be provided gamma table. You can calculate the probability using the gamma table. Or you can also use a spreadsheet to directly calculate the probability from the for the gamma function. Okay, now we'll go over an example. Suppose the time is spent by a randomly selected student who uses a terminal connected to a local time sharing computer facility and who has a gamma distribution with mean 20 minutes and variance 80 minutes. Be careful here. For the gamma function, you need two parameters, alpha, beta. They are not the mean and variance like normal distribution. For normal distributions, the parameters are mu and sigma. So they are mean and standard deviation. But in case of gamma distribution, you have two parameters, alpha, beta. They are not the mean or standard deviation. They are called location parameter and scale parameter. Alpha is the location parameter and beta is the scale parameter. But they are not the mean and standard deviation. You have to calculate the mean and standard deviation using those two parameters. So what is the mean? Mean is alpha times beta, multiplication of these two parameters. Mu is equals to alpha times beta. So which is here in this case, the mean is 20. So mu is equal alpha times beta, and it is given that mu is 20. So 20 is equal alpha times beta. And we are also given the variance is sigma square, and which we know that alpha times beta square. So sigma square is 80, then it will be alpha times beta square. Now we have to solve these two equations for alpha and beta. So how can we calculate alpha and beta from these two equations? So from here, you can calculate, you can write 80 is equals to alpha beta times beta, right? Because we have beta square. So we can just write alpha times beta because we have beta square. Now 80 is equal alpha times beta is 20. So we can plug in this number for alpha and beta. And we have this one. Now if you divide both sides by 20, then we can cancel out this one. And if you cancel out this one, then it will be 4. So that's mean beta is equal 4. So we know the value of beta here. Now plug in the value of alpha, value of beta, and find the value of alpha. Then it will be alpha is equal 5. So the parameter alpha is equal 5 and beta is 4. Okay, so now we know the value of the both parameters. In part B, we have to find the probability where x is at most 24. Part B is what is the probability that a student uses the terminal for at most 24 minutes. That's mean x is less than equal 24. The maximum value of x could be 24. So we have to find the probability where x is less than equal 24. That's mean f24. Okay, so when you will be using the table, you have to be very careful. The table which is given is for beta is equal 1, but here our beta is not 1, beta is 4. And f24 means 24 over 4, because x over beta, x is 24 and beta is 4. So that's why we have 24 over 4. And alpha is 5. So 24 over 4, 5, it will be f of 6, 5. Now we can go to the table and you can see here, this table is for fx alpha. That's mean beta is equal 1. We are considering beta is equal 1 for this table. Okay. So now you can see our if this is the CDF fx alpha. The first one is x, second one is alpha, and this column represents the value of x. So this is x, and this row represents the value of alpha. So the first number is in the first column and the second number is in the first row. Now we have to find the probability where first number is 6, second number is 5. Now go to the table, and along the column we have 6, and here we have 5. So that's mean the number will be this one, 0.715. So the probability is 0.715. So this probability is 0.715. Is it clear? Any question? Okay, the next one is, what is the probability that a student spends between 20 and 40 minutes using the terminal? So the next question is, x is between 20 and 40. So you have to use CDF, F40 minus F20. Now calculate the value of x. The beta is, we know beta is 4, alpha is 5. So the first one is x over beta. So first one is x over beta, and second one is alpha. So x is 40, so 40 over 4. So alpha is 5, and beta is 4. So x over beta means 4 over 40 minus, if x is 20, so 20 over 4 comma 5. So first one will be f10 5 minus f5 5. Now we have to look at these two number and these two number to find the probability. So if you go to the table, the first one is 10 5. So this number is 10 and this is 5. Then it will be 0.971. 0.971. So this is 0.971. And the next one is f55. So you have to look at, for x is 5 and alpha is also 5. So x is 5 here and alpha is 5 here. So that's been, this is 0.560. So if 55 is 0.560. Now if you simplify this one, then it will be 0.411. In part D, you have to find the 90th percentile. Determine the 90th percentile of time spent using the terminal. 90th percentile means you have to find the value of x for which the density on the left side of x is 90%. So that's mean the probability on the left side of x is 0.90. So here, actually, I think there is a mistake here. Okay, so here f of x over 4, 5 is equal 0.90. Now, this is the probability and this is alpha. So we know these two numbers, but we do not know this number, right? We have to find this number. So how can we find this number? So alpha is 5, that's fine. This is 5, and the probability is 90. Now in this column where we have 90, 90 is here, right? So the corresponding value of x when the probability is 90 is 8. So this number is 8. This number is 8. And in our case, this number is x over beta. So that's mean x over 4. So we have x over 4 is equal 8. So x will be then 32. X is not actually 8 here. X will be then 32. Is it clear? Any question?
Yeah, I have a question.
Yeah, sure.
So x, we just multiply it times 4. It's always going to be over 4.
Oh, no. Always going to be over beta. X over beta.
Oh, okay, but in this case, beta is 4.
Yeah, is
So we
in this
multiply
case beta
times
is
4.
4. Yeah.
Okay, okay,
Yeah,
thank you.
but yeah, you're welcome. So but in the table here, x beta is 1. You can see here if x alpha, so that's mean x is divided by just 1, right? So beta is just 1. So this is the standard case of for gamma distribution. Yeah, good question. Yeah, thank you. So now I'll ask you two follow-up question here. So you have part A, so B will be find the median, and C is find Q3. So these two questions are also part of your quiz. Yeah, B and C. So you have already A, right? You have already A. For today's class, you have already A, and now you have B and C. B and C means uh, this is separate from B and C from for the original questions, not part B and C from the original question. Maybe I should use different numbering. Otherwise, you will get confused.
Quick question. What do you mean
Yes.
by Q1, 2, 3?
Okay, Q1 means quartile 1, and Q2 means quartile 2, Q3 means quartile 3. That's been first quartile, second quartile, third quartile. Yeah. Is it clear?
Yeah.
Okay, good question. Thank you. Okay, B was, yeah, A was finding the Q1 and Q3 for example earlier. Yeah, you're right. Thank you. Okay, so this is all about chapter 4. Now we'll start chapter 5. Any question? For gamma distribution, I'm not sure whether you can calculate it using direct using calculator, but you can use a spreadsheet to calculate the probability from the uh, gamma distribution, I guess. Yeah, but I'm not sure about the calculator. Okay, so from this chapter, we'll just cover section 5.3 and 5.4. On the syllabus, maybe we wanted to cover only section 5.4 anyway, because we also need to discuss section 5.3. Okay, so this chapter is about statistics and their distributions. So what is statistics? Statistics is from the first class, from the first class of the probability, that statistics is related to sample or population. Statistics is related to sample, right? And parameters are related to population. Yeah. Yes, sample. Thank you. So now we will, in this chapter, we'll discuss about the distributions of statistics. So we'll discuss about different type of statistics and their distribution. Since the statistics comes from sample, and sample are random sample and related to random variable, so statistics is also random. So since statistics is random, so it is also a random variable and it should have some distribution. Okay. So statistics is a quantity whose value can be calculated from sample data. So before obtaining the data and after obtaining the data, so before obtaining the data, it is uncertain what value a statistic will take. For example, so before obtaining the data, for example, if we want to know the sample average of a class, in our class we have total 53 students, so we want to take a sample of 10 students to know the average score in the first midterm for this class. So before selecting those 10 students, or before selecting those 10 scores, we do not know the value of the average, right? Once we select the 10 scores or 10 students, and if we then we know then it is certain what will be the value of the average of midterm for these 10 students. But before collecting the data, before obtaining the data, it is uncertain because we do not know which 10 students are going to be selected. And a statistics is a random variable. I already said that the statistic is a random variable, and this is so that's why we denoted it by capital letter. But after obtaining data, we know the observations, right? So that's mean the observations are for a random variable are we denoted by x1, x2, x3, the observations dot dot. So we use lowercase letter. So when we'll obtain the data, we'll use lowercase letter for the notation of statistics. Okay, so what is the difference between parameters? Parameters are the characteristic which is related to population, and statistics are the measurements which is related to sample. And the value of the parameter is fixed. So for a given population, the value of the parameter is fixed. But before collecting the data, the statistics is uncertain. The value of parameter is usually unknown to us in practice. Usually we do not know the value of the parameter. Usually it is unknown. For example, for normal distribution, mu and sigma square are the parameters. We have two parameters here. Usually we do not know the value of the parameter, but we know the value of the statistics after obtaining data, and we make inference about the value of the parameter based on the statistics. So parameters describe populations and statistics describe samples. Parameter has fixed value for a given population. So if you know your population, then the values for the parameter are fixed. And the statistics changes from sample to sample. So it depends on the sample. So every time if you select different sample, you will have different statistics. And value unknown in practice. We do not know the value in practice. And value is calculated for a given sample. Once you get the sample, you can calculate the value for that given sample. So now we'll discuss some definition. So first one is random samples. So the random variables, we have in random variables here, we have x1, x2, xn. They are said to form a random sample of size n if xi's are independent random variables. If the random variables are independent random variables and every xi has the same probability distribution. So if x is a random variable and it is, for example, it is normal distribution with mean, mu, and sigma square. Okay, a sample will be called a random sample or simple random sample if all the random variables are independent. They have to be independent. And every xi has the same probability distribution. So for example, if x1 follow normal distribution with mean mu and sigma square, then x2 also should be normal distribution with mean mu and sigma square. and x3 also normal distribution with mean mu and sigma square, and up to xn should be also normal distribution with mean mu and sigma square. So they should be independent and they should follow same probability distribution. Okay, so the simple random sample is also called independent and identically distributed. So this is denoted by IID. IID means independent and identically distributed. So that's mean the random variables are independent. So here you can see we have an example here, x1, x2 up to xn, IID, and they are normally distributed with mean mu is equal 100 and sigma square is 25. So what does it actually mean? This means that x1 is a random variable and which is normally distributed. That's mean x1 has normal distribution with mean 100 and variance 25. X2 is also normal distribution with mean mu 100 and variance 25. Similarly, x3 has the same distribution. Xn also has the same distributions. So they follow the same distribution. They are identically distributed. And the first I means they are also independent. So that's mean x1 doesn't depend on x2. X2 doesn't depend on the other random variables. They are independent. So that's the meaning of IID, independent and identically distributed. Okay, so why do we use sample? The sample is less costly and more quickly, and sometimes it is quite impossible to know the population. So in this case, actually, we collect sample and we make inference about the population. And this is the actually sampling is the practical way of gathering information. So the problem is if we use sampling, if we use sample to make inference about the population, there is chance that we will make some error. And that will be called random sampling error if we collect the sample randomly. Then it will be called, and the error in sampling will be called random sampling error. Okay, so why do we have random sampling error? Because the sample provides the data for only a portion of entire population. So for example, if we want to know the average of a class of 53 students, and if we only select 10 students, 10 students are just a portion of the class, not the entire class, right? So that's mean only based on the average of 10 students, if we make inference about the average of 53 students, they will not be same. There are some error. So the difference between the population and the statistics is the sampling error. And if we collect the sample randomly, then it will be called random sampling error. Okay, so the random sampling error is the deviation or difference between the statistic and the parameter. So the parameter value are the exact value of the population, but in most of the time we do not know the parameter value. So we collect the sample and based on the statistics we make inference about the population parameter. Okay, and the deviation between the statistic and the parameter is called the random sampling error. Is it clear? Now we'll go over an example. So here the IRS publishes annual figures on individual income tax returns. And for the year 2005, the IRS reported that the mean tax of individual income tax returns was $10,319. So this is the mean tax. in actuality, the IRS reported the mean tax of sample of 292,966 individual. So they reported the mean of this number of individual illustrated of the total number of returns. The total number of returns was about more than 130 million, but they didn't calculate the mean for the 130 million returns. They only selected this number of returns and they calculated the average for this one. So now the question is, identify the population under consideration. So what is the population in this case? The population means the all individual of our interest. So here our interest is the tax returns. So we have all individuals income tax returns for the year 2005. So here the population is because we are talking about the tax returns in 2005. So our interest is the tax returns in 2005. So the population will be all individual income tax returns for year 2005. Then part B is identify the variable under consideration. So what is the variable here? So the variable is amount of income tax or tax. Tax is the variable here because we are interested about income tax returns. So tax is the variable here. Then part C is the mean tax reported by IRS a sample mean or population mean? So is it a sample mean or population mean? So this mean, is it a sample mean or population mean? Anyone? Yes, they are sample mean. Thank you. Because this is the average for only this number of individuals for the sample, not for the total population. So that's mean this is the sample mean. And the sample mean is denoted by X bar. And the population mean is denoted by mu. So this is not mu, this is actually X bar. So now the next question is, should we expect the mean tax X bar of this number of returns sampled by IRS to be exactly the same as the mean tax? No, because we have total more than 130 million returns. And this mean is only for this number of returns. So this mean is not exactly the exactly the same as the mean tax mu. So that's mean there are some difference. This deviation is called random sampling error. Okay, so now the next thing is sampling distribution. So what is the sampling distribution? So if we take a sample from the population and if we calculate some statistics. So what are the statistics? Statistics means the measurements for the sample. So what type of measurements? We can calculate X bar, which is the mean. We can calculate X tilde. What is X tilde? Do you remember X tilde? What is X tilde? Anyone? Yes, X tilde is median. Thank you. Then for the sample, can we use this notation for the sample, sigma square? For sample, can we use sigma square for the variance? Okay, I got one answer. You said yes. Okay. So what is the difference between sigma square and S square? What is the difference between these two notation? Okay, so what is the difference between these two notation? Yeah, one is for sample and the other for population. So S is for actually S is for sample. S is not for population. Yeah. So sigma square is for population. Mu and sigma. Mu is mean for population, and sigma square is the variance for population. Yeah. So S is for sample. So in case of sample variance, we cannot use sigma square. Usually we use S square. This is the sample variance, and S is the sample standard deviations. So here X bar, X tilde, S square is all of them are statistics because they are the measurements of the sample. So that's why they are statistics and they are random. So since they are random variable, they should have some distribution. They should follow some distribution. And the distribution of any statistic is called sampling distribution. If we find the distribution for X bar, then it will be called sampling distribution for mean. If we find the distribution for X tilde, then it will be called the sampling distribution for median. If we find the distribution for S square, the variance, that will be the sampling distribution for variance. And if we find the distribution for S, that will be the sampling distribution for standard deviation. So the sampling distribution is the distribution of a statistic. If you find the probability distribution of a statistic, that will be called sampling distribution. So what is the difference between probability distribution and sampling probability distribution? The probability distribution is the distribution for a individual or single random variable. And the sampling probability distribution is the distribution of a statistic. I'm sorry. Okay, so how we develop a sampling distribution, we'll go over an example. So assume that there is a population of the basketball players and we have 5 observations in our population, and the players are denoted by A, B, C, D, E, and we have their height. So here the random variable is X is height. We have just one random variable, which is, sorry, no, not on random variables. So the random variable here is height, and the players are A, B, C, D, E. So we have the population size N is equal 5. Now we can take a sample from this population, right? The population size is 5. So now we can take different sample. So consider all possible samples of size N is equal to. So now we want to collect a sample where the sample size is 2. So that means we'll only select 2 players from these 5 players. Now, how many ways we can do this selection? So we can do the selection with replacement and without replacement. So with replacement means we have 5 players here, A, B, C, D, E. So with replacement means first you will select one player. Suppose the player is A. Now you will replace the player again and you will do the selection. So if you replace the player again in the population, then you will have A again here. You can select A again, right? So that means you can select A twice. But here we'll do the selection without replacement. But you can also do the selection with replacement. Then you will have more number of samples. Okay, so if we do the selection without replacements, then how many way we can select 2 person? We can select AB, we can select AC, we can select players AD, we can select players AE, we can select BC, BD, BE, we can select CD, CE, and DE. So we can, how many ways we can select? 2, 4, 5, 7, 10. So we can select 2% from these 5 players in 10 ways. So that's mean we can have 10 different samples, right? Because our sample is only size 2. And in how many ways we can select the samples? In 10 ways. So that's mean we have 10 samples here, right? So this is our first sample, this is our second sample, and their corresponding height. Now, for each sample, you can calculate the sample mean. So for example, the sample mean for the first sample, suppose this is x1 bar, and thus this is x2 bar. So we have total 10 samples. So for each sample, we'll have a sample mean. So how many means do we have now? We have 10 means here. So for the x bar, if x bar is our random variable, so how many observations we have now for x bar? We have 10 observations, right? And since they are random, now we can calculate we can construct the distribution, probability distributions for these observations or for this random variable. And this distribution will be called sampling distribution for the mean of size 2. Similarly, you can take samples with different size. You can consider 3 players for each sample, and you can do the selection in different ways. And for each selection, you can calculate the sample mean, and that mean will also follow some distribution. And that distribution will be called sampling distribution for the mean. Yes, you're right, 10. Yeah. So now we calculated the average for each sample. Now we have 10 average here. And if we construct the distribution for this 10 average, then it will look like this. This is the sample mean x bar. And this is actually the histogram. You can say this is histogram. And this is the shape of the distribution. And this distribution is called the sampling distribution. Okay, so this is the population distribution. So that's been the distribution for X. And this is the distribution for X bar. So this distribution is different from this one, right? Little different from this one. Okay. So is it clear what is sampling distribution and what is population distribution? Or do you have any question? Okay, good. Now we'll calculate the sampling error. So we have population size n, and if you calculate the population mean, the mean is 80, the mean of the total population, and if you calculate the mean is 80. And if you calculate, you can also calculate the population mean from the sampling distribution, and here the population mean is 80. Now you can see this is our population mean, and this is our sample mean for each sample. We have total 10 samples. So you can see that we have just one mean which is exactly equal 80. The other means are different. So you can see here, this is difference from 80. This mean also difference from 80. This mean also difference from 80, right? This mean also difference from 80. So that's mean the sample mean has some deviation with the population mean. So this deviation is called the sampling error. Now here we considered, we constructed the sampling distribution for size n equals to 4. So n equals to 4 means we'll select 4 players this time, and we'll calculate the sample mean. And this will also follow a distribution, which is also sampling distribution. Now you can see here the sampling distribution for different size of samples. Okay, here you will find a very interesting thing here. So here x bar n equals to 1. So that's mean this is the population distribution. So this is the distribution for all individual. So this is called the population distribution. Now you can see this is x bar for n equals to 2. You can see here and this is the x bar. This is the distribution when n equals to 3. This is the distribution when n equals to 4, and this is the distribution when n is equal 5. I'm sorry. So this is the when n is equal 1. So and this is n equal 5. So this is the population distribution, and this is the mean of population. So what do you see from this chart? So what is the interesting feature of this graph? Yes, you're right. Thank you. The bigger the sample size, the more concentrated the mean. Yes, that's absolutely correct. The more n, the more exact x bar will be. Yes, you're right. So you can see here, when the sample size become larger and larger, the deviation will become smaller, smaller, smaller. So that's mean when you consider large sample size, it will be close to the, and if you calculate the mean will be close to the population mean. If your sample size is small, it will be away from the population mean. That's mean you will have, when the sample size is smaller, you will have more error, more deviation. When the sample size is larger, you will have less deviation or less sampling error. Okay, so now you can see here the larger sample size, the smaller sampling error tends to be in estimating the population mean. And okay, then we'll construct the law of large numbers. And this is also a very interesting law. So here we have a class, in the class we have total 20 people, and we are interested in the average height of the class. So we want to calculate the average height of the class. So the average height is 65.95 inch. So this is the population mean. Now we'll do a simulation. Simulation means we'll take the sample and we'll construct the distribution of the for the mean. So among these 20 students, we selected 5 students and we selected all possible samples. Then we constructed the histogram for X bar. And this is the sample average and this is the frequency. So this is the frequency distribution for X bar. So that's mean this is the frequency distribution for mean. And since this is the distribution for mean, that's been distribution for statistics. So this is sampling distribution. And this is about this is the distribution of average height. That's why we'll call this is the sampling distribution of heights. Now the distribution is kind of bell shaped. Okay, so this is for n equals to 5. Now see when n equals to 10 and when n equals to 15. Now you can see when n is becoming larger, the distribution becoming more dense, more concentrated. You can see here. This is for n equals to 5. It's spreaded more, and n equals to 10. The deviation is less. When it goes to 15, the deviation is becoming more less. Okay. Now, what does the law of large number tells us? Law of large number means if you take larger sample, like sample size with if you consider large sample size, it tells us that our estimate of the population mean will get better, right? And you have already seen that if you take large sample, then the estimate of the population mean will get better. This means the variability of the sample mean decreases and as n increases. So if you increase the sample size, the variability of the mean will decrease. Okay. Actually, the law of large number also says, and we will also discuss this one later, which is called the central limit theorem, or CLT. We'll discuss this one in the next section. This is called, this is also related to law of large number, central limit theorem. Okay, so actually this theorem says that if n is large, then the distribution of the sampling distribution for the mean will be, the shape of the distribution will be bell shaped and will be close to normal. When n will become larger and larger, the distribution will become normal. Oh, okay, we didn't take the attendance yet. Yeah, yeah, we'll take the attendance. So if you consider n large, and if you construct the distribution for x bar, then regardless of the distribution of the population, whether the population distribution is skewed or bell shaped or left is skewed, the regardless of the distribution of the population, the distribution of sample will be, sample mean will be close to normal distribution, or will be approximately normal distribution if n is large number. And we'll discuss this one in the next section. So I'll stop here today, and now I will take the attendance. So you should type present now.